All right, this is quick notes on double replacement reactions. And what we got going on is the definition first. So a basic simplified definition is two compounds react to form two different compounds. That's the simplified definition. Two compounds react to form two different compounds. So if you see a situation with two compounds, it's probably double replacement, at least in this class. The more technical definition is when you have two binary compounds, ionic compounds, react so that the cations of both compounds switch places. That would be a more technical definition. So when solving, let's solve number one. It says write the reactants. All right, I've got the reactants. I then need to identify the cations and anions. Another way of saying that is put up the charges. So write out all the charges. Yep, this is the same thing as single replacement, except instead of a single element, we have two compounds.
Oh, okay.
So, but yeah, it's very similar. Right, Jacob? All right. All right, so sodium's +1. Because on the periodic table, it's in the first column, it's +1. Also, sodium right there, +1 on the polyatomic ion sheet. And chlorine is -1. Halogens are -1. Silver is always +1. That's one of my exceptions. And nitrates -1 because it says so on the polyatomic ion sheet. All right, so I got all my charges placed up there. I then have to pair up each cation with the anion from the other compound. So this is similar to the single replacement. I'm still going to switch things. Only here, I'm just going to focus on the cations. Silver and sodium, the positively charged ions, are going to switch. All right, so I'm going to have silver with chlorine, and I'm going to have sodium with nitrate. And could I put NaNO3 first and then AgCl second? Yes, doesn't matter. I'm going to carry over the charges so I can balance these. +1, -1, +1, -1. These are both 0. And I've got a sodium on each side, a chlorine, a silver, and a nitrate. So it's already balanced on both sides 0. Before I do anything more, let's figure out what the definition or what the procedure is. It says switch. I don't know, this isn't my procedure that I do. A better way of saying it, in my opinion, would be make sure that the products are correctly written. So correctly write the products. So after you switch the cations, you make sure that the products that are produced are correctly balanced. You then want to write the states for the products. All right, and that's going to be found on your, not your activity series, but your solubility table. And this is nice ACT practice because we're looking at a chart and using it to come up with some data. So I'm looking at silver chloride. I want to figure out, is that a solid or aqueous? So silver chloride. I got to look at the anion chloride, which is right here. And then I got to look at, is silver found anywhere in here? Yes, it is. It's right there. So it falls under the solid category. So silver chloride is solid. Silver chloride is solid. Sodium nitrate. If I'm good at memorizing, I'll know that nitrates are always aqueous. But I can look at the solubility chart. Nitrates. No common cations form a solid. So it's going to be most cations aqueous. All right. And rule of thumb is, for the reaction to occur, you must have one solid and one aqueous product. If you have two aqueous products, it's a no reaction. If you got two solid products, it's a no reaction. So you got to have one solid and one aqueous. And that is, oh, the last part. Balance using coefficients. All right. And we already kind of established that it's already balanced. All right. So try number 2, MgOH. Mg is +2, because in column 2, that's where magnesium is, +2. Hydroxide's 1-, because on the polyatomic ion sheet, it's a -1 hydroxide. K is +1, because it's in column 1, and iodine is -1, because it's in a halogen column. All right, what do you do after you state the charges? You swap them. So pair up each cation, swap the cations. So Mg and K are positive, those are going to swap. So K goes with OH, and Mg goes with I. Notice how I'm not carrying over the 2. I'm going to balance it later. So iodine's 1-, magnesium's 2+, hydroxide 1-, potassium 1+. +1 - 1, that's a correct molecule. I didn't need to have 2 OHs. I got a crisscross. So the charge of magnesium says I need 2 iodines. All right. And for fun, let's just balance it. We got 2 iodines. I got 2 iodines. 2 Ks. I got 2 Ks. 2 OHs. 2 OHs. And it's balanced. But maybe this doesn't occur. So let's see. I need to have a solid and aqueous product. So KOH. So I'm looking at OH is right here. And K is in column 1 on the periodic table. So cations are column 1 and 2. So that's column 1 or 2. Those are going to be aqueous. And K is definitely in column 1. So column 1 or 2 is going to be aqueous. So KOH is AQ. And then MgI2. So iodine is right here. And Mg, is it any of these elements, Mg? No, it's not. So it's not a solid, so it's going to be most cations, which is aqueous.
Does precipitate mean solid?
Yeah, precipitate is solid.
So would precipitation mean the opposite of solid? So that's
well, those are two words that sound similar but are meaning two different things. So they're not related. Two aqueous products means this reaction does not occur. So the actual answer is NR, no reaction. All right, doing one more. Iron. I don't know the charge of iron, but why don't we reverse crisscross it? 3 O's means that's the charge of iron. We're almost done with this. Calcium's 2+, sulfate's 2-. I'm just looking up on my polyatomic ion sheet for those. All right, so Jaden, what's my first product going to look like?
Ca.
That's a C. Yep. Did you just guess that?
No, I knew that.
Would it be
S.
F?
No. O.
Oh, you got
you
it.
said that halfway when we was done.
And then Fe. So.
There you go. So those are the two products. We got to make sure they're written correctly. So I carry over the charges. Ca is 2+, O is 2-, so that balances it out. But we got to crisscross this. We need 2 irons and 3 sulfates. There we go. Before I balance both sides of the arrow, I might not need to balance them. So I'm going to possibly save myself time if this is a no reaction. So CaO. Oxygen's right here. Cations in columns 1 and 2. Calcium's in column 2. So that's going to fall under the aqueous category. Uh-oh, we need to have a solid for this reaction to occur. So iron sulfate. I'm looking at sulfate is right there. And iron, is it any of these elements? No, it's most cations, therefore aqueous. So if I have two aqueous products, the answer is no reaction for that. And I don't have to balance it because it's a no reaction. All right. So that's double replacement reactions.